Now we shall discuss the solution of second order homogeneous linear difference equations with constant coefficients. So the first equation here is to solve yk plus 2 minus 2yk plus 1 minus 3yk equal to 0. This is a second order linear difference equation because here the highest argument is k plus 2, the lowest argument is k, so the difference between k plus 2 and k is 2, so it is second order. It is homogeneous because right hand side is 0. It is linear because there is no yk terms multiplied with itself or with any other yk plus 1 or yk plus 2 terms, and even it is having the constant coefficient. So it is a very simple type of difference equation we have here to solve, and this question has been asked in the examination of 2017 for 2 marks. So how to solve this example? Let us see. First step is to write this equation in terms of the shift operators. So if on yk we apply the shift operator e, it gives us one jump, that is yk plus 1. If shift operator is operated 2 times, it gives us yk plus 2. So therefore on yk, if we apply e square, that is e square of yk is yk plus 2. Therefore yk plus 2 has been written like e square of yk minus 2 into, this becomes e of yk because one shift. So e of yk is yk plus 1, therefore this yk plus 1 has been written as e of yk minus 3 as it is. So on RHS 0 as it is. After expressing the given equation in this form, that is the form in which we find the shift operators, now we can write the auxiliary equation in a very simple way by replacing e by r. So wherever e is there in this bracket, let us replace that by r and equate to 0. So to get an equation, an algebraic equation in terms of r, particularly in this case we are getting a second degree equation, that is a quadratic equation in r. It is called the auxiliary equation. So what are the roots of this equation that we have to find out? So in this case it is very simple because the factorization can be done here because the factors are minus 3 and plus 1. So as to have minus 2, minus 3 plus 1, if we multiply we get minus 3. So therefore the factorization is r square as it is minus 3r plus r. So minus 3r plus r gives us minus 2r. At the same time, minus 3 into 1 gives us minus 3. So therefore we can write the above equation in this format, and after that we can take r common between the first and second terms, so as to have r minus 3 within the bracket, plus in between second and third and fourth terms, let us take 1 common, so as to have r as it is minus 3 as it is in the bracket, and an RHS 0 as it is. In the next step, here in between these two terms, r minus 3 bracket is a common factor. If we take it outside, here remains r, here remains plus 1, so that is equal to 0. In the next step, it gives us r minus 3 equal to 0, r plus 1 equal to 0. So from this one can get the values of r as 3 here, and from this minus 1. So the roots are real roots. So the numbers are real numbers and they are different numbers. So the roots are real and distinct. So once we have the real and distinct roots, we know the procedure of writing the general solution. Then the yk equals to, it is c1 into the first root, that is r1. r1 here is 3 to the power, the independent variable is k. So therefore it is c1 into the first root to the power k plus c2 into the second root is minus 1 minus 1 to the power k. So this procedure I have explained you in a very better manner in the previous video. So please look at that video. So you will get the idea how to write the general solution directly. So in this case, the real roots, distinct roots were existing, and because of that we have written the general solution in this format. So this completes the solution of the first example. Let us consider the second example. 16yx plus 2 minus 8yx plus 1 plus yx equal to 0. It should be understood here that in this case the independent variable is x instead of k, which we had in the previous example. Whatever it may be, either k or x, we have to proceed in the same way. So the given equation should be written in the in terms of the shift operator in the first step. That is the coefficients, the constant coefficients we are having in this category of difference equations. So the constant coefficient 16 as it is, yx plus 2 can be written as e square of yx. So yx I will write here outside the bracket. So e square of yx, that is yx plus 2, minus 8 into e yx, that is yx plus 1, plus 1 yx, so it is 1 here, yx outside, that is equal to 0 on RHS. So the given difference equation has been expressed in terms of the shift operator like this. After expressing like this, we can very easily write the auxiliary equation simply by replacing e with r. Wherever e is there, let us write r. So it is minus 8r plus 1 equated to 0. So now it is a quadratic equation, an algebraic equation in R. Now we have to solve this equation for R. So let us see whether the factorization is possible or not. So if we multiply, we should get 16, and if we add, we should get minus 8. So what are the factors? Minus 4 and minus 4. So if we have minus 4 and minus 4, their sum gives us minus 8 and their product gives us 16. So therefore, we can write this equation as 16r square as it is. This minus 8r can be written as 4r with minus sign, and here one more minus 4r. Minus 4 minus 4. So minus 4r, that is minus 8r. And plus 1 at the end as it is. Now, between the first and second terms, we can take 4r common, so as to have 4r here for the first term, minus 1 here for the second term. Similarly here, if we take minus 1 as the common factor, in this case let us take minus 1 as the common factor, then we will have 4r here with positive sign, plus 1 is there, it becomes minus 1 because minus 1 has been taken outside, so that is equal to 0. Now here these two brackets are common, so let us take 4r minus 1 bracket common here outside, so as to have 4r here for the first term, minus 1 for the second term. So we are having the first bracket 4r minus 1 equal to 0, the second bracket 4r minus 1 equal to 0. From the first we get r equal to, if we take this minus 1 to that side, it becomes plus 1. If we take this 4 to that side, it comes to the denominator because it is multiplied here. It will be divided if we take it to the other side. So it is 1 by 4. Here also it is r equal to, in the same way it is 1, and here it is by 4. So it is 1 by 4. Therefore, r is 1 by 4 comma 1 by 4. So what type of roots we are having? The real roots we are having, but they are identical. Real and identical roots we are having in this case. Once we have the real and identical roots, what is the way of writing the general solution? Then the general solution is for yx, because the unknown here is yx, you can observe. Yx equals to c1 in the bracket plus the independent variable x into c2, whatever root we are getting here, 1 by 4 to the power x. So this is how we can write the general solution. So what is the way? C1 plus x C2 r to the power x. So the values of r are 1 by 4, 1 by 4, real and identical roots. Therefore, this is the required general solution of the given difference equation. So this completes the solution. It has asked in the examination of 2017 and 2019. Twice it has been asked in the examination, 2017 as well as in the examination of 2019. This question has appeared. So thank you for watching the solution of this example.